So what's this talk about? It's uh, it's about the birth and rise of an important language. It's about um, what's around it about in the security implications and the fact that when we talk about this path JavaScript is taking, I will try to tell about the path of all important technology are taking today, and also, of course, about that path. During that path, what are the security implications and how to deal with real-world issues. Of course, this is not about saying JavaScript is an insecure language, because anyone, no one can say it, because it's just a language. It's not a framework that has bugs in it. You build things with that one. So it's about how it's used. Let's just start with a brief history, and let's start when JavaScript first came out, and it was 1996. Also, it was the first time that it was implemented in Netscape 2. And think about that. Before that, the browser was just a simple HTML parser. Nothing happened. HTML pages were ugly. Also, after 3 years, the first Ajax framework comes out. Then, since 1999, something is going to happen. We can see it because implementation of new features are being put there by vendors. And let's go straight forward to 2009, and we can see that in the last 5 years, we have so many new features inside the JavaScript universe, actually inside the browsers, and why it's going like that? Because vendors' browser are trying to push the use I try to push to improve the user experience, and of course, something that sounds like a plan. It's something that sounds like a plan because actually there are several features here. It's about giving 3D graphics. It's about giving audio and also speed improvement. And guess what's the glue of all these features? It's JavaScript. So this is the big picture of the history of JavaScript and the implementation of the new feature. We can see that there is a big gap of since 1996 to 2009, where almost nothing happens, and then boom, there's a growth of new features out there. So let's just talk about the past, and let's see what happens. So when JavaScript enters in the internet world, in the web world, it was in order to improve the user experience. That kind of new feature in the browser let HTML page programmer, let's say that, let's call it that way, uh, to read content, to modify it on the fly. What same origin policy is a way to understand if a page belongs, if a page can read another, the content of another page according to their origin. The origin is the server that hosts them, and so it's about matching the triple scheme, host name, and port. So evil.com cannot access bank.google.com or bank.com. It's not possible because of the implementation of these rules. This is very important because this is what we deal with every day. Because we actually, when we use the browser, but also when we use a mobile device, we deal with sandboxes. We deal with several layers of software that try to understand if some feature can be called, is allowed to be called by someone or not. This implementation of access control in a hostile environment is called sandbox. The first way to subvert these rules happens for the first time in 1997, maybe 1998, on a mailing list. And it was about, hey, but if I can just inject, just send some data to the server, to Google, and Google stores it or takes it and then use that to build the response for some other user, will be possible for me to add new content, to add new JavaScript, to add new HTML. That was called for the first time cross-site scripting, which is actually HTML injection. That was the first way to think about how to bypass the sandbox. There is another way to bypass the sandbox. Is about, do not think about the browser, but think about what can be run on the browser. Plugins. In fact, let's suppose a user has a plugin that behaves completely in a completely different manner, like Flash plugin. I think everyone has it in their laptop, or the whole Acrobat Reader PDF. And what if that plugin gives more features, but there were no implementation of any sandbox because they didn't care? But the browser, yes, but the plugin didn't. So the attacker can just abuse a new functionality from a plugin to attack the browser's victim. In order to what? To access data. Data is what is important at the moment. If it's possible, something like that, then we can call it universal cross-site scripting. So if a browser can load a plugin which is vulnerable to some kind of abuse, actually a malicious attacker could access data from any site, from anywhere, no matter what the browser sandbox does. Just an example. This is what I found late in 2006. It was the first time that the term of universal cross-site scripting was used. Let's suppose, and it was on a Acrobat Reader plugin. Let's suppose Google just hosts a PDF. So anyone can reach it using that URL. Now, the attacker knows that almost anyone has a plugin that reads PDFs in the browser, directly in the browser, and at that time, that plugin was nearly in every PC, on every PC, and was Acrobat Reader. Well, actually, I found that it was possible to add, after the URL, actually some parameter that could be abused in order to execute JavaScript. And since JavaScript, since the PDF was hosted on the server, it was possible to actually execute anything, which means read, modify, cancel, delete any information in the page that belonged to the hosting server. So the other question was, but what if an attacker is able to point the victim's browser to a PDF inside her machine? The same thing, but at the local file system level. So the attacker had the possibility to read the whole files in the file system of the victim's browser. Of course, after plugins, there are extensions. I think by now everyone uses at least one extension in their browser, and actually they are most of the time built with JavaScript inside, and of course, since they are extension, have more power than usual JavaScript in a page. No? Also, extension could be malicious. We've seen malicious apps on the Android Play Store. It's kind of the same, but for extension. If the browser vendor misses some check, they could be just try to wait for a user to install them and steal all the data. We have to be really careful with when installing extension. We don't know where they come from. Or simply, they could be badly written. So they can expose your browser to attacks like the PDF previously mentioned, or worse, like executing code inside your machine. Meantime, on the server side, we have an experiment, JavaScript running as a framework for web applications. Early implementation of JavaScript, it was 2003, and Netscape tried to put on the market JavaScript server side. So in 2003, people used to code like that. And that is a very wrong way to code in JavaScript. First of all, because there is eval. There is a saying, eval is evil. Because eval is a method that can be quite easily abused. And in this case, since eval is actually executing JavaScript, an attacker could create a way to execute JavaScript, execute command on the server side by injecting JavaScript and let the server to execute also access to file system and command execution and so on. So this was actually a bank application. and it was written in 2003, and I was engaged to uh, test it in 2008. So they were at least exposed without knowing anything to remote code execution, a bank, for at least 5 years. Meantime, on a user's PC, what's happening? We've seen by looking at the history that there is one time where new features are becoming to be implemented more and more, no? Yeah, it's around 2005. Something more interesting happens. Those new features, like Ajax, starts to gain interest on the industry world. So the cost of computers lowers. So the platform, the user base grows, and the platform, those several platforms are converging to a common one, which is the browser. Everyone is going to use the browser to do things because it's easy to implement a web application, and everybody has a browser. No one has to download and install a new application in order to just interact with the bank and so on. But big user base, big money, a lot of data, the crime comes in, and comes in because of one reason, only one reason, to profit about that. So in 2005, maybe now we are more aware about that, but in 2005, a dialogue like that presented several times a day, and we just have to choose if to run or save something. We didn't know if it was secure to run. But most of the time, a naive user would click run because it's the one highlighted most of the time. And that's what happens at that time. When they click run, something inside their machine happens. The virus, it was theorized, since the browser is a common, now is a common interface, common platform, there is also a way to just use it and gain everything. One move and get everything. So what happens here is that we take advantage of the common interface of the browser, and this kind of malware, which is called the banking malware, just tries to change the content of a bank on the fly and hijack the data that are used by the user to another, to create new operations. So it's a win-win for the crime, because the sandbox is completely bypassed, because it's on top of the browser. We don't have to deal with the sandbox and stuff like that. It's a perfect sandbox bypass. We want to see, maybe someone have already seen what's a Zeus. Zeus is a malware, it's a banking malware. This is a configuration example of a banking malware. The first part, where there is set URL, is when the banking malware has to activate if the user is going over there. If the user is visiting that URL, then the banking malware has to trap the response from the server, find the name equal password part inside the server, inside the response, and inject those other lines. What are those other lines? Are the secret question for changing password, probably, or for a password forgot stuff. So the banking malware adds something new for the to the user experience or user's page, so that the user will consider it trusted because it's trustful, because it's coming from the bank side, and voila, it will just answer those questions. And when they click OK, is not those answers will not go to the bank, but will go to the banking malware, which will send them to the attacker. Meantime, on the mobile, what's happening? It's 2005 and 11, and already there is iOS, of course. Already there is Android, maybe. But what's very interesting is that since browsers are so famous, so used, of course, every operating system has to give a component that acts like the browser to the apps. So an app will be able to embed a window, a browser window inside itself, and use it and interact with that. In 2011, SuperEver, which is a very nice guy and very smart, found on iOS Skype app this HTML injection here, and which lead to the possibility to read everything Skype could read. So execute JavaScript inside an app is not like executing JavaScript inside a browser. It's completely different because the rules are changed because an app is on a sandbox that allows to do more things than on a classical laptop browser. Just another note before going to present. In 2011, always, there is a lot of websites and a very big user base by now, and advertising and programs to perform analytics about the traffic and so on, improvement for user interaction, and good libraries for improving graphical and so on are out there. Everything is written in JavaScript, and actually that kind of worried me, because JavaScript was we are talking about hundreds of kilobytes of JavaScript code to analyze. It's not very easy. And for each page. So I created a tool whose name is Dominator, which is a Firefox modification, and helps to, just while browsing the page, helps to track the JavaScript execution and try to identify if the data can be controlled by an attacker, and if that data goes somewhere that could be abused, and alerts it in order to take actions against. In 2011, I took the first 100 sites ranked in the Alexa ranking. And I found, using the tool, that 57 sites were exposed to some kind of cross-site scripting using JavaScript, abusing JavaScript weaknesses, coding weaknesses. Okay, now this is what happened until a couple of years ago. What's now? Actually, the past stuff, what we've already talked about, is still there. No one really solved most of the things we've talked about before, previously. Yeah, some effort is being done by vendors. One is called is a kind of improvement of same origin policy. So it's possible to improve the granularity of about how a web page interacts with external sites and external windows and so on. But even if browser have already implemented it, they are content security policy ready. There is a very few web applications that implement them, that kind of policy. So it is not still a real solution. Also, we are trying to patch, to build, to improve something that was written in 1997. It's a very old model. It's kind of not fitting quite anymore now. And there's more, because the market is pushing and pushing and pushing, and PCs are always faster, and JavaScript is faster again. So what's the new thing that is coming out in the last 2 years? Welcome to the new way to dynamically create content, generate content on the fly on the client side. Welcome to HTML templates. Welcome to client-side full dynamic content, also known as AngularJS and all the siblings around it. How it works. The green one is the template. You see there is no actual content there. There is just some HTML tag and something surrounded by parentheses, which is quantity asterisk cost. And what are those? Those are called, that one is an expression and is not directly executed by the browser JavaScript parser, but is executed by the framework, is parsed by the framework using what's called expression parser, and which is implemented on top of JS. So it's a sandbox over another sandbox built on top of JavaScript. And the data is actually taken from the server or from a database in the browser or from whatever. So it's completely isolated, the template and the data, which is called data binding. So one could say, okay, but I can just try to inject stuff like that and see what the expression parser can execute, since it goes to the JavaScript parser. No, because the sandbox actually removes all the dangerous objects in order to prevent kind of sandbox bypass attacks. No? But as any sandbox, the sandbox is a program. The program is written by human beings, like everyone here. So we are not perfect, and there could be some flow inside. Security is a process. It's not just a solution I give you. So it's a long process when the implementation is complex. And here is a very mind-blowing sandbox bypass. So there is no more easy alert there, but there is a way to try to access the function constructor and call it with the alert one you can see over there, which is the malicious payload, of course. Oh, there is a new problem. Since the user content is generated on the client, what happens if the web application should create a PDF out of the user content page and save it on its side, on the server side? It's a real problem because everything is generated on the client by the browser. There are some steps to do. Go on the browser, extract the generated HTML, send it to the server, and use a browser on the server to recreate the graphics and convert it to PDF using browser capabilities. Is there something wrong here? So the server generates HTML and then regenerates using a browser somewhere over there at the server side. Really? No, absolutely. There is something wrong here. And you know why? Because if you have running a browser on the server side, you are having all the feature we were seeing before on the server side this time. Is a complete different security model here. So the attacker this time is a user that sends a fake HTML page to the server. The server just sends it to the browser, and the browser what does? Execute it and create, if it sees something like that, it creates a request to an internal router or to an internal server. That's what happens if you try to use a browser on the server side. Write access to the whole internal network on the server, and that means actually create arbitrary requests on the web application side. And now, for something completely different, JavaScript in the full web stack. Why? Because there is another phenomenon happening since a couple of years, even more, 3, 4. Again, JavaScript on the server side. And since JavaScript is gaining more popularity, there are a lot of homemade developers that they think they know how to write good JavaScript. Well, actually happened with PHP as well some years ago. What happens is that there is a new toy, and the toy is called Node.js, and is actually a way to create a web application using JavaScript directly on the server side using only JavaScript. Also, welcome back to 2003. We've seen before what could happen. Also, there is another interesting layer here, which is JavaScript in the database. One of the most favorite software that does that is MongoDB. So it's A classical stack on the server side is Node.js, MongoDB. So, is there a real difference? Someone could say, no, but there's not real difference because, yeah, well, there is HTTP, the request comes, everything is like writing Java web application or C#.NET web application and so on. Yes and no. Why? Because let's try to write a very simple application using Node.js and just send a request like that and print how the request and how the parameters are treated on Node.js. We send a couple of parameters with a couple of values over there, and what happens? Happens that in this case, since parameter is repeated more than once, on the server side is actually considered as an array of vector or of values. And what if we add parentheses and give some value to those parentheses? Well, the Node.js treats it as it was a JavaScript object. So it's way different from how JavaScript or classical framework server behave. Also, let's build something that uses Node.js and MongoDB as a backend layer. The question is, since it's a DB, is still possible to execute SQL injection? Anybody knows what SQL injection is? Okay. So, can I try to inject something like 1 equals 1 or 1 equals 1 and so on? Let's see. Let's create a very simple Node.js application with MongoDB database. And let's use this very simple line of code. Try to find the user was created by the user is populated by the request with a password paired with the user. Let's test the environment. Let's see if that request, what happens if I send that kind of request to the Node.js. We send user equals a username, ampersand pass as equals a password, and we see that Node sees that like that. So it's a JavaScript object. Let's take a step back and let's go to the MongoDB documentation, and we find that there is a very nice page that tells us if you want to do something using classical SQL and if you want to do the same using querying MongoDB. And we can see that there are 3 or 4 ways to actually create something like or 1 equals 1, which is that one. There are a couple of keywords that starts with the dollar symbol, NE, dollar NE, which is actually not equal. So it become user not equal username and password not equal password. This is most of the time, if you are very unlucky, there will be a username with a password value credential, but you must be very unlucky. And that one actually allows you to directly log in without knowing anything about any user. and most of the time the first username is the administrator. So just see. Okay, let's talk about the future. What's going on here? We've seen all those interesting features in the last that have been implemented in the last couple of years. Sound, OpenGL, 3D graphics, everything inside the browser using JavaScript. That is, there is one of the reasons out there is to improve experience for web gaming. So we can run, for example, Quake or other 3D engine. Like there is actually a real Unreal Engine that can be compiled in something that is called asm.js and actually have speeds near the native execution, near 1.5, so half lower, but still very usable. And you will have something like that in your browser, full screen, no plugins. Can you see there is more user base coming in the JavaScript universe using new features, and that will push new feature again. The implementation of new stuff is always introducing new bugs. Also, let's go on the mobile side. There is also a new operative system that Mozilla is pushing. It's Firefox OS, which actually with which you can create a mobile application by using HTML and JavaScript. I created a very simple application just with one file HTML and one configuration file with extension web app. That one will be able to execute JavaScript in the sandbox, in the application sandbox. But what happens is like having a new extension in your browser. No? You don't know if that application is written well. You don't know if it's malicious or not. Some part is up to the vendors to control if something is malicious or not, because they use their marketplace to expose them to you. But still, it's your responsibility to keep an eye open on that. Also, these are the last two things. The Internet of Things, what is Internet of Things? Is hardware, programmable hardware. Since JavaScript is very, very popular, they are putting the JS interpreter in a chip in order to let everyone program that hardware. So since everyone everyone that can use JavaScript can program it, everyone can do it the wrong way and can code badly and so on. There is also rumors that someone is trying to create an operative system from scratch using Node.js as a base. So, okay, conclusion. We are living in a world that changes faster than before, and everything is pushed by market. We are the real product, of course, but we users, because the more we use things, the more experience we want to do, the more things will be implemented, and the more surface will be open to attackers. New interesting technologies could get a huge user base in a matter of a few months, and when happens, everything gets even faster. And since it's even faster, the developers cannot have the time to understand if there are security implications in what they are doing. And they will try to patch something quickly because they are running together with the world. So while they are coding, people is downloading their application, and they are being exposed to attackers. So also, JavaScript is used by a lot of people, really, really a lot of people, because it seems very easy at the beginning. But still, we have seen in the sandbox bypass before, it can be very complicated. And there are the same things can be done in like 10 ways, different ways. So things are get even harder, and the only thing we can do is try to study and to try to go deep into things and understand the technology we use and the technology we try to improve. Can you see it now, what's going on? I really can't even think how much intricated the implementation of new features will be in the next years. And this is only one language, the JavaScript part, and the browser framework and what it's around it. I only hope that it's going to be like a ball of wool with some fancy design drawing on it. So I'm done. Thank you. If you have any question, I think we have 5 minutes, like. Microphone? Ah, okay.
Hola.
Hola.
¿Te puedo formular en español la pregunta?
No, por favor.
If JavaScript is not the best to provide security to the app to the server database data and something, why not to use only server-side language to get the privacy data and client-side coding only for front-end of the application?
Okay, you mean just like go back to client server, classical client server?
Yeah, something like that, yeah.
Yeah, it's something, of course, we could, it depends what we can control, right? So if you are creating a web application for your employer or for you, you can choose your technologies. You can choose the technology you know best. So probably you will choose, because you think about it, your model. The problem is that we can control something, but we also are users. And what we use is something that we cannot really control because it was developed and created by other people and vendors. So if a vendor tries to push for a technology, well, it's industry, baby, no? It's you are going to choose if to not buy that technology, but it's your own choice in the end, and you are just not getting advantages from that technology because of your choice as a user. As a programmer, as a developer, of course you can do whatever you want. It depends what are your objectives, your targets.
Okay, thank you.
Any other question?
Hello. How can we make JavaScript
Say?
more
Ah,
secure?
okay.
Can we use cryptographic techniques maybe?
Okay. Let's say that coding is hard for each language because it's not about uh, having a secure language. There is no such thing, you know. It's about having when you build a house, you are not actually putting bricks casually, you know, randomly. You just you try to have a project. You try to know how big the wall must be, and so on. So there is a process that has to be followed, and it's uh, it's about quality, and also when you have a process for quality, you can also have a process for security. So implement something that helps you to control how you are coding, and if there is some good way to work around in a safe way some bad solution, some bad choice you are taking. So it's more about understanding the way to improve security in the process of software development, and not also, of course, add cryptography, for example. But that is just another technology on top of something you are writing. We have HTTPS that can protect the communication, yes, but an application that uses HTTPS on the server side and has a bug, HTTPS won't protect for abusing that bug, because it's not taking part anymore in that case. Okay, so it's just one layer more, but the thing is that the process must be improved in order to get quality in the code you're writing. Same thing for Java, .NET, and so on. Another question over there?
Hi. Hi. Okay. What do you think about CSP? Will be used in the future, or will just be a nice idea with no implementation? I don't know.
Big company probably will use it. It depends. First of all, right now the really big problem is advertising. JavaScript created for creating banners and stuff like that. That they use old JavaScript full of bad functions and so on. So if they would implement CSP, advertising would stop. So the whole market around it would stop. At the moment, it's kind of hard to correctly implement, I mean, CSP as a whole idea. I guess, for example, Twitter, Facebook, Google already implemented it. Well, they are in the board, so they want to implement it because they are creating it. The problem is when we deal, for example, with a bank that do not implement CSP, we tell them, you should add these headers to your responses. They do, but they don't know what they are doing. They just do it because we are telling them. But what if it breaks something else? No? I think it's very mature as a technology right now because we are running very fast with the old technologies and all the code. No? Maybe in 5 years it will be better. There will be more implementation of that.
Okay, thank you.